So in this lecture we are going to discuss upon the equations of motion. Equations of motion are based upon uniform motion where the acceleration is constant. There are basically three equations of motion. V is equals to u plus at, S is equals to ut plus half at square, and the third equation is v square is equals to u square plus 2as. Out of this, the v stands for the final velocity, and u stands for the initial velocity, t stands for the time, and a stands for the acceleration. S stands for displacement. Also, this equation S is equals to ut plus half at, it has another form. When we take the displacement from another point except from the origin, so S1 is equal to S0 plus ut plus half at square. This would be when we don't measure the displacement from the given point. For small heights, the gravitational acceleration is taken to be 9.8 meters per second square. If we take upwards as positive, this is known as sign convention. Never to be confused, whenever we solve any numerical, we should always decide whether we take upwards or downwards as positive, and after that the opposite side would be negative, and then all the vector quantities will come and run with that. So when dealing with small heights, the acceleration due to gravity would be negative 9.8 meters per second in this case. Now there are few formulas or shortcuts we need to keep in mind which are derived from the equations of motion. Whenever we say that a body is released from a certain height, released means the initial velocity is 0. Therefore, it will have certain height, also the time of descent because it is coming down, and a velocity with which it will strike. So the formulas are as follows. Whenever u is equal to 0, v, the final velocity while hitting the ground, would be equal to square root of 2gh, and the time of descent would be equal to square root of 2h by g. Now in the case when the final velocity is equal to 0 or thrown vertically upwards, with the where the initial velocity is not equal to 0, but the final velocity is equal to 0 at the h max. Some car, for example, which is moving ahead with certain velocity u, would come to a rest due to the retardation, that is negative acceleration, and its final velocity would be equal to 0. Whenever we reach the h max is calculated by u square upon 2g. Time of ascent, that is the time taken to reach the h max, that is the maximum height, that is known as the time of ascent, that is also equal to u by g. Now the time of ascent would occur twice, that is it would go up once, the velocity would be equal to 0, then it would come back again to from where it had come. So then the total time would be equal to 2u by g. A ball is thrown upwards from the top of a tower of 40-meter high. A ball is thrown upwards from a tower with a velocity of 10 meters per second. Find the time when it strikes the ground. Over here we are taking upwards as positive. We can directly substitute the values in the equation s is equals to ut plus half at square. S over here is 40, negative 40, and u is 10. Time is unknown, plus half negative 10 t square. 40 is equals to 10 t plus negative 5t square, and by solving this quadratic we would get t is equals to 4 seconds and t is equals to negative 2 seconds. Out of that we will discard the value t is equals to negative 2 seconds because for this case we need the time to be positive. So the value of the time when it strikes the ground would be 4 seconds. Ball is thrown upwards from the ground with an initial speed u. The ball is at a height of 80 meters at 2 times. The time interval being 6 seconds. This is the time interval. Now this is an important word. the time interval when it crosses this line twice is 6 seconds. That means from A to B would be 3 seconds and from B to C would be 3 seconds. So G is given as 10 meters per second square. If we take upwards as positive, G would be negative 10 meters per second square. Over here again we can use the equation of motion. The S is given to be 80 meters, U is given to be unknown, T is 3 seconds. The thing we are doing over here is that we are going to calculate. Over here the V will be equal to 0 from the point A to point B. So we'll calculate the U over here. When we get the value of U dash over here, we will equate it to V. Use the same equation from point O to point A by using U dash as V. This would be equal to U and U is unknown. So S is equals to UT plus half A T square, which is equal to 80 3U plus negative 5 into 9, and if we simplify this we would get U dash is equals to 30, U dash is equals to 30 meters per second. Now this is the value of U dash, but we are not finding the value of U dash, we are finding the value of U. So it would be V square is U dash square, that is 30 square is equals to U square is unknown plus 2 into negative 10 into S 80. 30 square is 900, U square plus negative 20 into 80. 900 is equals to U square minus 20 into 80 is 1600. So we get the value of U square to be equal to 2500. U is plus minus 50 meters per second. Over here we consider the value to be positive, so the answer will be 50 meters per second. So now let us see the derivation of the first equation of motion. Acceleration is the rate of change of velocity. That is, acceleration is equal to the change in velocity upon the change in time, final minus initial upon t. So A is equal to v minus u upon t. If we write it in, if we send v to one side, we get v is equals to u plus at. And this is the first equation of motion. This was algebraic method. Now we will derive the first equation of motion by calculus. Acceleration is equals to the first derivative of velocity with respect to time, and we could write it as dv is equals to a dt. Integrating both the sides we get dv is equals to a integration dt. Now we know that at t equal to 0 velocity was u, and at t equals to t the velocity was equal to v, or we could write it as v minus u is equals to at. All this we get v is equals to u plus at. So now let us derive the second equation of motion by algebraic method, and that average speed is equals to final plus initial by 2. This is the average. Similarly, we know that speed is equals to distance upon time. So distance will be equal to speed into time. If we insert the value of v as v plus u upon 2 into time, and if we insert the value of v from the first equation as u plus at plus u upon 2 into time, we get s as 2u plus at upon 2 into time. Dividing this, we get s is equals to u plus at by 2 into time. S is equals to ut plus half at square. And this is the second equation of motion which we derived from the algebraic method. Now let us derive the second equation of motion by calculus. We know that ds is equal to v dt. ds is equals to u plus at into dt. At time t equal to 0, suppose s is also equal to 0. Integrating both sides ds and u plus at into dt. So when time is equal to 0, we know that the displacement was also 0, and when time was equal to t, the displacement was equal to s. By this we get s is equals to ut plus half at square. So now let us derive the third equation of motion by algebraic method. We know that v is equals to u plus at and acceleration is equals to v minus u upon t. Displacement is equals to speed into time, and speed is equals to final plus in average speed is equals to final plus initial by 2. So s is equals to v plus u upon 2 into the time, that is v minus u upon a. When we multiply this, we get v square minus vu plus uv minus u square upon 2a. So we get s is equals to v square, vu and uv get cancelled, we get v square minus u square upon 2a. V square is equals to u square plus 2as. They have given the value of x as 20 plus t cube minus 12t. They have asked for the position velocity of the particle at t equal to 0. At t equal to 0, we get the position to be 20 meters, and we insert the value of t as 0. Then we get this answer. Similarly, for the velocity at t equal to 0, what we do is we differentiate displacement with respect to time. So we get 3t square minus 12, and at t equal to 0 it would be equal to negative 12 meters per second. Similarly, state whether the motion is uniformly accelerated or not. To find whether the motion is uniformly accelerated, we will differentiate this equation again and we would get 60, which shows that differentiation of equation 2 with respect to time t, we get acceleration as 60. As acceleration is a function of time, the motion is non-uniformly accelerated. Similarly, in the third question, they are asking for the position of the particle when the velocity is 0. When velocity is equal to 0, in equation 2, 2 seconds, and by this time interval, we can insert it in the formula x is equals to 20t. So by substituting t equals to 2 seconds in equation 1, we would get the position of the particle when velocity is 0. The position of that particle would be 20 plus t cube, that is 2 cube minus 12 into 2. This would give us x as 4 meters, and this is the answer of the question. In this question, velocity is given as a function of time and we need to find the displacement of the particle from the mean position at t equals to 1 second. If it is given that displacement is 20 meters at t equals to 0. We know velocity is ds upon dt. Integrating both sides, we would get ds is equals to integration of t is equals to 0. We know that the displacement is 20 meters, and when t equals to 1 second, the displacement is unknown. We would get the value of displacement to be 32 meters. Similarly, they have asked us to find out the acceleration time equation. That is the differentiation of 10 plus 2t plus 3t square, 2 plus 6t.